guys, Mrs. Traver here. Today we're going to talk about similarity. Our learning target is the ability to use equivalent ratios to find missing links of similar figures and learn how congruent figures are similar with a side ratio of 1. You know you'll be successful when you can use a proportion to solve for missing side lengths. We're going to look through the assignment today, take some notes, and then you'll have practice afterwards. Let's jump in. First things first, I'd like to look at this picture of two triangles and compare their side lengths. So notice you've got triangle ABC, the little one, and then bigger triangle A prime, which is in the same spot, B prime and C prime. And then I've got all of these side lengths, which really side lengths should have lines over top of them, so I'm going to put that so we can notice our notation as well. Let's look at all of these side lengths. So in the little triangle, I'm looking at BC. This side is definitely 4 if I count up the boxes. CA is across the bottom, that's 1, 2, 3, 4, 5, 6. And then AB is on a diagonal. We actually have to find this with the Pythagorean theorem, so let's go off to the side and do that. So I'd have 3 squared plus 4 squared equals AB, we can call it, squared. 3 squared plus 4 squared is 9 plus 16 is 25, equals AB squared. So that means that the length of AB is 5. Okay, so I've got a 4, 6, 5. Let's look at, hold on, CA, I think I wrote that down wrong. That should be a 3, my bad. I was looking at C prime, A prime, which is 6. Okay, we fixed it. B prime, C prime, so we're talking about this length here. That's 1, 2, 3, 4, 5, 6, 7, 8. And then A prime, B prime, we could do another Pythagorean theorem here, or you might notice what's going on. Let's compare. We went from 4 to 8, we went from 3 to 6. Do you think we'll go from 5 to 10? I think so. If you check it with Pythagorean theorem, you will. What we're going to start noticing here is what's called scale factor. Scale factor is what it got multiplied by, and if it got multiplied by a number bigger than 1, then it's going to get bigger, and if it's a number smaller than 1, it'll get smaller. Let's try another one. Let's see if we can set up a proportion. So if we match up sides, side AB goes with side A prime, B prime. Side BC goes with side B prime, C prime. And side AC goes with side A prime, C prime. So if you notice, I'm going to write the fractions right below it. AB was 5 and A prime, B prime was 10. BC was 4 and B prime, C prime was 8. And AC was 3 and A prime, B prime was 6. So all of these are really the same fraction because it was 1/2 the size for side ABC compared to A prime, B prime, C prime. All right, moving forward, let's look at a shape like this and see if we can match it up. We're looking for the scale factor. So the first thing I like to do is match up sides, and this one's pretty obvious, but some of them it's kind of weird because they're turned and things. So what I do is I match sides up. If you can circle the 8 and the 24 and recognize that they correspond to each other, and then we do a box for the other one so that they look different, we can see what got multiplied. So 8 times what is 24, and 6 times what is 18. 8 times 3 is 24, and 6 times 3 is 18. So in this case, our scale factor is times 3. Our book sometimes calls this a zoom factor. Either one is fine. Here's another one. And this time, notice I've got an X and a Y. Let's match things up to start. I'm going to circle the 8 and the 24. And notice that from 8 to 24, it went times 3. Let's see if we can match up another set. I'm going to match up the 11 with the box to the X. So we know in the same setup it's going to be 11 times 3 is X. So therefore X must be 33. And then lastly, let's do our Y. We went from Y to 18. So it'd be Y times 3 again equals 18. What would Y have had to be? It would have had to have been, if you divide both sides by 3, Y would have been 6. So in this case, Y is 6. This is one way to work it out, especially when your scale factor is an even number, not even number, a whole number like 2 or 3. All right, here's another setup. Now, this one we're going to use proportions because it's not going to be able to set up like the last one. Let's match sides up again. 8 goes with 12, and here's where we run into an issue. 8 times something to get to 12. The other ones we were able to easily think about what that would be. But this one, 8 times like no whole number is 12. So we're gonna have to do this problem a little bit differently. Let's first match up our sides. The 10 goes with the 15, and the 6 goes with the 9. So if we're going to try to figure out the proportion here, I could look at any of these setups. So all of them are going to end up being the same. Let me start with the green one, my 8 and my 12. If I just do left over right, 8 over 12, and let's make this be a decimal, you get 0.6 repeating. If we try the red ones, so that'd be the 10 and the 15, and see what we get there. It's also 0.6 repeating. And then lastly, if we try the blue ones, 6 over 9, we're going to get 0.6 repeating again. So in this case, the scale factor from here to here, it went from 10 to 15. We had to multiply by that. Here's another one, and we're looking for the error. It says Lynn claims that these figures are not similar. When she compared the heights, she wrote 2 over 7. Then she compared the bases and got 21 over 6. Notice those are different fractions, so she's saying therefore they're not similar. Why is she having trouble? Let's see if we can help her. So I'm going to match up 2 and 7 and put 2 over 7. And if they're similar, it should equal the other ones, 6 and 21. So I've got 6 and 21. Notice I went left, right, or small, big. I need to go small, big again. These should be equal if they're similar. And notice what she did is she flipped this one. Let's check and see if ours are similar by seeing if these two fractions are equal. So if these two fractions are equal, we'll be good. 2 over, whoops, not 2 over 4. 2 over 7 is this number. And 6 over 21, is that same number. So these are equal, they are similar. She flip-flopped her fraction. All right, I've got 3 more to try, and that'll wrap us up for today. Let's match up sides. So 2 goes to 4. This one I can recognize the scale factor is times 2. So therefore I can do the same thing here. 6 times 2 is x, so x is 12. Let's try another. I'm going to match up sides again, and let's be a little bit careful. If I match 4 up with 6, that's not going to work. Notice 4 is the short side. That goes with 3. So from 4 to 3, I don't see anything I can multiply by. So I'm going to end out setting up a proportion. I'm going to go big over little. And then when I do my other one, I just have to make sure I do the same thing. Oops. So I've got x over 6 equals x over 6. Here I can cross multiply to solve. So I've got 6 times 4 is 24 equals 3 times x is 3x. Divide by 3 on both sides, and I've got x equals 8. Now looking at my length here, that looks pretty reasonable to me that would be 8. My last one, C. Let's see what we can do. I'm going to match up the x with the 21, and the 3 is going to go with whatever this side is. So I don't know what this side is. Notice they gave me some more information that the perimeter is 60. I think I can find this side to match up with 3. If this is 21, so is this one. And then I would have used how much so far? Let's see. If I start with a total of 60 for my perimeter, and I take away 21 and 21 again, I'm left with 18 to split between the two sides. So I would say that these must both have to be 9s. Okay, so now I can match 3 to 9. Notice from 3 to 9 it was a times 3 situation, so I'm going to do times 3 again. X times 3 is 21. That means x must be 7. Alright guys, that's going to wrap us up for today. I hope this helped you guys out. We're going to continue looking at similar figures as well as congruent figures as we move forward. See you next time.